welcome to TJ International Education. Today we are going to do a detailed tutorial about American Mathematics Competition Talk. My name is Henry. You can call me Harvey. Before we start this course, it's very important to know the instructor, which is me. My name is Thierry Young, so of course Thierry is my first name and my last name is Young. You can also call me Harvey because I like the American suits Harvey Specter. I like to. My dream is always to become a lawyer. To some extent, I was born and raised in Harbin, China, which is a very far away city from Beijing. It is cold, but it's considered very beautiful in winter. And then after I finished my high school year, I studied in Nanjing University of Science and Technology for 1 year. And then all of a sudden, I realized that the major that I study is not really suitable for me. So I decided to study abroad. And then the reason I choose Canada because Canada is a really safe country and famous for high quality education. So of course, naturally, I studied abroad for 2 years at Cape Breton University and 2 years at the Harvard University. In order to get my engineering degree. It's also important to getting to know what I participate in every day. For example, in the first picture that you can see, we were we were just joining as a volunteer for a basketball match at the court of CBU gym. Me and my friends, we were having fun. So this is the first picture. We were at the basketball court. And the second picture is, um, I think roughly it was taken in 2018 at the Dalhousie University second campus. So at that time, I was still a CBU student, second year, holding the CBU student card. And me and my friend Doug Debo, we were joining in a thermodynamics experiment for second year electrical engineering students. So actually, me, I studied electrical, and he studied mechanical engineering. The third one is just a brief through on a very historical wall at the engineering campus. At the engineering campus. So this is what you can see here. Me and my friend Raj, we were attending the CBU engineering, not just engineering, but for all graduation convocation. So we were holding our diploma, dressing in suits. And this is the Dalhousie University logo that I always remember because I spent my school years over there. Before we start our official course, I would like to introduce one of the most beautiful equation in the world, which is called Euler's equation. So this one states that e to the power of I pi plus 1 equal to 0. So here is an interesting fact about this is that right here, I is equal to square root of negative 1. So it's always impossible to see in reality that a square is negative. But when you study the chapter in Pure Mathematics 4 and Pure Mathematics 3, is talking about the complex number. So things about complex number is usually negative. So you can just regard I as the unit imaginary number on x-axis. On x-axis. And of course, J and K will just be as following the unit imaginary number on y-axis and the unitary imaginary number AMC. So some people will belong to pi, and some people will belong to I. Pi really say, hey, man, you cannot do this. You're gonna be staying real. Well, I will say, well, as a man in this world, no matter what you are dealing with, you're gonna be rational. So you have to be flexible. So these represent these two people. And another group of people is called E. So E will say that, hey, hey, Pi, once we unite together, we are going to be one. So this is a pretty interesting joke that I want to share with you guys. Next one. Next one, we are going to talk a little bit about the AMC context and its principle. The mission of the American mathematics competition is to increase interest in mathematics and to develop problem solving skill and fun competition. So this fun competition includes actually four parts, which is trigonometry, advanced algebra, advanced geometry, and applied mathematics and strategy, which is basically all covered in high school materials, no matter you're studying A-level courses or your AP courses or IB courses. This this test, this context will definitely be a very important challenge for you. And if you pass this test, then it'll be a really nice step to a really high level university. It will be a really significant pace on your way to G5 or the world's top university. And the teachers and schools benefit from the chance to challenge students with interesting mathematical questions that align with curriculum standards. So all the questions that we are going to talk about in this tutorial and the future AMC courses will be focusing on all levels of difficulty. And in addition, the students will gain a lot of opportunity to learn and achieve through competition with students in their school and around the world. So this competition is held worldwide. Another thing about American mathematics context is that American mathematics competition is a series of examinations. So it's not just the one exam. We have AMC 8, AMC 10, and AMC 12 at the same time. And the important curriculum materials builds a problem solving skills and also the mathematical knowledge in the middle of the high school students. So it's very important to consider all the problems in a skill format or solve it in a mathematical strategy. And the mathematical knowledge in the middle of high school student is always important so that after you cover the materials of the AS and A2 level math, for example, you already went over pure mathematics 1 to pure mathematics 4, and you finished the mechanics and the future math. I deeply suggest that these students to prepare for this context. It's very important for your university application. So the AMC 8 is the AMC's middle school level competition. It's really for grade 8 students. And the AMC 10 and AMC 12 is the American Mathematics Competition's high school level competition. So it is mainly for high school students, especially for students who have AS level structures base. So which means this AMC 12 context, it will be relatively easier to finish pure mathematics 1 and pure mathematics 2. So today we will focus on AMC 12 and some real exam problems. The duration for the test is also very important. Before we get into the real exam problems, we need to know the structure of the exam. The AMC 12 is based on 25 questions. These questions focuses on topics of trigonometry, advanced algebra, advanced geometry, advanced applied mathematics, and also strategy questions. And the strategy questions in the advanced algebra are usually the main parts. So the advanced algebra and mathematics are usually the main part. Are usually the main part. And the duration is 75 minutes. So which means you have like 3 minutes per section. So you don't have that many time to think about different strategies. When you got an idea about the question, just go ahead and focus on it. Yeah, and this question is a multiple choice examination, which means there's no free response questions for the first round of AMC. But there will be long division questions in the future, second round and third round until you get the gold medal. If you are aiming at getting a medal, then it's very important to study both multiple choice question and free response question at the same time. And to cover the entire school curriculum, we must have a lot of things to memorize. So it's very important to keep the formula sheet of context one, context two in your hand, not just trigonometry. What is the trigonometry formulas? For example, the trigonometry part will require you to know what is fundamental identities. For example, what is sine, what is cosine, what is tangent, and also the addition and subtraction laws of them. For example, sine x plus y equals to sine x cosine y plus cosine x sine y, and a lot of formulas like that. This exam requires that as a prerequisite. Okay, and advanced algebra includes logarithmic functions, vectors, and also a lot of other things. Uh, the main things, the main things will probably be the things that we cover in AS level, which is like sort of like uh, logarithmic functions, exponential function, and a lot of other things that we mentioned cover. So before you take this test, you have to have a little bit common ideas about what is algebra, what is logarithmic and exponential function, what is geometry, and techniques about taking differentiation equations, numerical solutions of equations, vectors, and a little bit about complex numbers. So these are all very, very important. But all the things here are excluding calculus. So when you solve questions, you can just take integration and differentiation out of your brain because that is not the main part that we focus on EMC law. And also, this context is designed such that no background in analysis or any higher mathematics needed to take the exam. So We don't really need to know what is integration differentiation, how that applied in a real math problem, but we need to have a little bit analytical thinking about higher level mathematics that is needed to take the exams. And now let's try some questions about the exam. Before we try the actual exam questions, I want you to understand the definition of pain. So suppose that on Monday you have $400 in your bank, okay? And then on Tuesday you have $600. So the net balance from the Monday to Tuesday will be delta B. We sort of rated this in the form of delta. The delta means the change in money amount, okay? Which means the change from $400 to $600. I'm just going to write delta B1 as the change from Monday to Tuesday, okay? So it will roughly be, it's easy to calculate, right? $600 minus $400, which is equal to $200, $200. And then this will be the difference or the night budget or the change, whatever you call it, for your bank balance from Monday to Tuesday. And then from Tuesday to Wednesday, there will be a deduction of $300. So of course, I'm going to write delta B again, but this time is always equal to B final minus B initial. The B final, the final amount, the initial amount purely depends on the reference frame that we choose. If we choose Monday at the beginning, Tuesday at the ending, then B initial will just be Monday, and then B final will just be Tuesday. But if we choose Tuesday as the beginning and Wednesday at the ending, then our amount will just be um, initial the initial amount as 600 for Tuesday and final amount at 300 for Wednesday. So it's very important about which reference frame you choose. Now have a look at the check your understanding question. As you can see, I listed most of the data here, so you can just have a look at the question. Have a look at the question. Here we have like 3 different days, which is June 1969, June 1999, and June 2019. And the height of the water levels in Lake Mad at 3 times is also shown here. So if you know that, if you understand what I defined by changing the previous page, it's very easy to calculate the answer for it. So delta H1 will just be equal to the first height and the second height difference, which is usually equal to height final minus height initial, right? Then it will be equal to 12.1206.40 minus 1141.79. And if you do have a calculator, please use it. I'm going to calculate the number right now, which is 12.06.4 minus 1141.79, which is roughly 64.61 feet. And of course, this is going to be positive. So positive 64.61. And then the next height that we're going to calculate is between this and this. Okay. So you can see the final height is shorter than the initial height. So I assume this outcome is going to be negative. So it's going to be 1,084.71 minus 1,206.4, which is equal to negative 121.69 feet. Okay, so after we calculate all these answers, we will choose. I think the answer is going to be 40 feet. Okay, now is some real problems. This problem is categorized as geometry with numbers. Okay, have a look at the question. We use like let's say we use like 2 minutes to look at the question. So this question right here says Nankara has 4 multiplied 6 index card. So it's better to build a diagram here stating that the length and the width is 4 and 6. Usually length is longer than width, so I'm going to write length as 6 units, and I'm going to write the width as 4 units. If she shortens the length of one side of the card by 1 inch, the card would have area 18 square inches. Okay, so let's shorten one of them and see what happens. If I shorten this, if I shorten this by 1 inch, then this will be decreased to 5 units. Okay, and this one will stay in 4 units for the same. And the area will be equal to 4.4 times 5, which is roughly 20 square inches. Okay, which is exactly not what I asked for E, 118. So how about deduct the waste for one? So we just deduct the waste for 1 unit, reduce it to 3 units. Okay, reduce it to 3 units. This one is going to be 60 units. And then 6 multiplied by 3 exactly 8. Okay? So that's why this is one of the choice. The other one is 20 square inches. So what would the area of the card be in square inches if instead she shortens the length of the side by 1 inch, which means technically we are choosing the first option because the second option is already fixed. So it's going to be 20 square units right over here. So that's what we choose. So this is a geometry with some numbers, mainly focusing on numbers because we actually didn't talk about the definition. Right? Okay. So see, we finished this problem in like less than 3 minutes, roughly like 1 minute. So getting a problem like this done within 3 minutes is really doable. Next one, what is the value of 2,112 minus 2,021 squared over 160? It is really important to simplify this. A good way to simplify it is just to calculate whatever is in the bracket. So first the step is to calculate things inside the bracket. Calculate things inside the bracket, which is 2112 minus 2021, which is just like roughly equal to 90. So this whole thing turns into 91 square over 169. And people who is sensitive to numbers will know that 169 is equal to 13 square. So this whole thing will just be converted to 91 square over 13 square. And we know that by in this law, a over b, a square over b square is equal to a over b square. This is very important that we do. So 91 divided by 13 is going to be 7. And 7 squared is going to be equal to 40. Okay, so it's very easy to choose C. Next one is a long strategy question. Just to read through the question first and we'll talk about it. So it says that this man has a choice of two routes to get to work. So, for example, you go to work at a regular morning, and you can either choose route A to go to work or route B, but they have different distance. One is 6 miles long. So we're going to just extract the important information. So route A is 6 miles long. Okay, 6 miles. And his running pace, his average speed along the route is 30 miles per hour. So of course it's not going to be walking, it's driving. So it's going to be 6 miles per hour. I'm going to write the velocity as 55, sorry, 30 miles per hour when it is approaching to the destination. So the first rules will just roughly take 6 miles over 30 miles per hour, which is roughly equal to 0.2 hours, equal to 12 minutes. So this is how long time it takes for them to finish the first route, to finish the first route. Okay. And then route B. Route B is 5 miles long. Route B is 5 miles long, but it has to be divided into two parts because except the half-mile stretch in the school zone, all the other areas it's just an average speed of 40 miles per hour. So you can just sort of derive route B as two parts. One is 4.5 miles, and the other one is half mile. The other one is half mile. So the time taken for passing the non-school zone will be equal to 4.5 miles over 40 miles per hour, which is roughly equal to a number, okay? A number. I'll just write this as uh, velocity. I just write this as time one, okay? And then the school zone, we're gonna write it as 1 over 5, all 2 miles over 14, not just 40 anymore, I'm sorry. Uh, whereas average speed 20 miles an hour, so I'm just going to divide by 20 miles an hour, which is going to be equal to like roughly P2, P2, okay? P2. And then by calculation, we will know that P1 plus P2 will be equal to 11 over 80 hours. This is easy calculation, okay? This is just what we do in the beginning of AS level physics chapter 1 when you study kinematics. Just very easy to calculate uh, the time frame when you have the root and the velocity. So 11 over 80 hours can be converted to minus 2. So 11 over 80 hours times 60 will be roughly equal to 8 and a quarter minutes. So the time difference will just be 12 minutes for root 8 minus 8 and a quarter minutes for root B, which is roughly equal to 3.75 or 3 over 4. So it's very easy to choose like the answer is B. Now let's use 30 seconds to go over that and you get a better feeling about how to solve these kind of strategy questions. Just studying all our ideas and do the calculation. Next one is a number theory problem. Number theory problem is usually one of the hardest part that you can ever know in AMC competition. So let's have a look at this. This six-digit number 20210A is a prime. So it's very important to know what exactly is prime. Prime number means technically, if the write this down, prime number means technically the number can be just expressed by a factor of itself as one, which means it is the number that can be factored out only with itself and one. So it cannot be, so just to think logically, this number cannot be a factor of 2 because once it has a factor of 2, then there will be three factors. 1 itself 2. So the ending number, so the ending number for this will not be 2, 4, 6, 8, 8, and 0. Since all these numbers can be divided by 2, it cannot be these numbers. It cannot also be a positive like cannot be a it cannot be like a multiple of 5 too. So so the ending number of 0 and 5 is also true. Do you think it can be a multiple of 3? No, not really. Because if it has a multiple of 3, then there will be at least the 3 multiples. Itself, 1 and 3. Then it cannot be a multiple of 3. Which is technically representing that 2 plus 0 plus 2 plus 1 plus 0 plus 8, which is equal to 5 plus 8 equal to 9. So then A will just be equal to 9 minus 5, which is 4. It cannot be equal to 4. We should already exclude it here. So this already excluded 9. Also, it cannot be a multiple of 9 since it cannot be a positive multiple of 3. So A cannot be equal to 2, 4, 6, 8, 0, 5, and 4. So therefore, the answer key is going to be um, A not equal to 2, 4, 8, 8, 0, 4, 5. Can it be equal to 7? It can't, because it cannot be equal to be a multiple of 11. So therefore, this one is a advanced algebra question. It also has a little bit of strategy belonging to it. So we are going to talk about this question a little bit later. Now have a look at the advanced geometry question, which is this one. You can use like 2 minutes to look at it. As shown in the figure below, point P less than the octave up plane determined by the CD from point A to that angle CDE is 110 degrees. So which means from the question we know that angle CDE is 110 degrees and the point F less than AD less than A. Oh, sorry, I think it's going to be point. Yes, point F and DE equals to DF. DE equals to DF. So these two angles are equal. It's very important to draw the extension line. That's DK. And then we can just do a little bit of angle arrangement. Since angle EDC is equal to angle CDK plus angle EDK, okay, and also angle CDK equals to 90 degrees, then angle EDK is going to be equal to 20 degrees. And since that this one is 20 degrees, this one is going to be 20 degrees. This one is going to be 20 degrees. Since this is the equilibrium point, and angle D and angle DEF equals to angle DFE because of the fact that DF equals to DE. So equal sign matches equal to this one, this one. And therefore, angle AFE will be 180 degrees, which is angle AFE minus angle DFE, which is 170. So we can choose choice. This is an applied math question. Have a look at it. A school has 100 students and 5 teachers. In the first period, each student is taking one class. So it's very important to know that each student is just simply taking one class instead of conflicting with other classes, so that we don't need to involve combination and permutations into this problem. And each teacher is teaching one class. This is also very important so that every teacher has equivalent likelihood, which 1/5 or 20% of getting one class out of these 5 classes. So these 5 classes has a class capacity of 50 students, 20 students, 20 students, 5 students, and 5 students. So I would like to first introduce the general formula of expected value. So you can either write sigma sign down here or no. So I choose not to write it. So expected value of of a theoretical outcome the will be the percent of outcome multiplied by theoretical probability. So this is going to be our general formula. So if you apply the same thing here, the expected value in total will just be equal to number of enrollments times equal likelihood, which is 20%, plus the other class, which is the second class, numbers of enrollments times equal likelihood, plus the third class multiplied by the equal likelihood, plus the fourth class multiplied by the equal likelihood, plus the fifth, which is exactly like this. So adding up all those numbers in total, we just substitute 1/5 odd, which is 1/5 times 50 plus 20 plus 20 plus 5 plus 5, which is 100 times 1/5, which is 20. And as is a discrete random variable, which is down here, right over here, let S be the average value of the first student we get, right? So the S value would just be equivalent to the probability of one student being selected all the students. So I'm going to use number of students, the first class multiplied by the probability of one of the students that's selected from all the students, which is 100 students, plus 20 multiplied by 20/100, same thing, plus 20 times 20/100, plus 5 multiplied by 5/100, and so on and so on. So the total amount from here will just be 25 plus 4 plus 4 plus 0.25 plus 0.25, which is roughly 33.5. So here, t minus x will just be equal to 20 minus 33.5, which is negative 13.5. So the negative 13.5 will just be our final value for this discrete random variable function. So that's why we choose B. Next one is advanced algebra and geometry. So this question is talking about right rectangular prism. So it's advanced algebra, of course, because it involves logarithmic function, uh, but it's also related to a little bit of 3D geometry. So a rectangular prism will sort of look like this. Will sort of look like this. We draw a perpendicular line down here, line down here, and try to cross all of these together to get the rectangular prism. So a rectangular cube or prism has length, width, and height. So whatever you define it, you have to offer the reference frame towards it. So I want to divide this one and define this as height, okay? And I'm going to define this as length. And then I'm going to define this one as width. All right. It might not seem very precise for length and width, but I'm trying my best to draw this rectangular figure. So a very important thing for this is that the surface area and the surface area and the volume formula is kind of different. So the surface area will be equal to 2 times width and length product plus length and height product plus width and height products. Okay, which means two cross-sectional surfaces, the other perpendicular cross-sectional surfaces, and two parallel surfaces from the bottom and the top. And also the volume of it will just be equal to width times length times height. Width times length times height. Okay. So therefore, we can just sort of get surface by using surface area equal to volume. We can get the equation. The 2 log 2x log 3x plus log 2x log 3x, and then plus log 3x log 4x will be equal to log 2x log 3x multiplied by log 4x. So this is the mathematical equation that we will obtain. Well, how to solve this equation is very important thing. How about we use common denominator formula? Like we divide log 2x, log 3x, and log 4x on both right-hand sides of that. So which will give us a standard equation like this. Log 4x, 1 over log 4x plus 1 over log 3x plus 1 over log 2x equal to log 2x, log 3x, log 4x over log 2x, log 3x, log 4x, which is equal to 1. Once you ever get this formula down, we can apply another technique. So this is a very important technique. Without this technique, we cannot finish the problem, which is for standardized logarithmic function, we have log a at base, b at power equals to 1 over log b at base, b at power. So we can just sort of like inflate it out, inflate it out, inflate it out. And then by converging this, we get 2 times log x4 plus log x3 plus log x2 equal to 1. And then 2 times log x24 will be 1. And log x24 squared will be equal to 1. Then x will be 24 squared. Then 12 multiplied by 12 multiplied by 4, which is 576. So that's why we choose E. See, it involves a lot of mathematical calculations, so it's very important to review a little bit about things like trigonometry, exponential function, logarithmic functions prior to your test. This one is a mathematical logic one. So it requires some sort of knowledge prior to what you possibly know about base 10 representation. So mathematically, we have base 10, base 9, base 8, base 6, and base 2 representation. Technically, it means like this. If I write the formula here, you will sort of understand what I'm saying. So for example, this is 27 slash 006 slash 000 slash 052. This expression. Then for the first one, we can just conclude that this one is going to be equivalent to 2 times 9 to the power of 10 plus 7 times 9 to the power of 9 plus 6 times 9 to the power of 6 plus 5 times 9 to the power of 1 plus 2 times 9 to the power of 0. So this is exactly like how you convert base 9 representations into base 2 representations. I'll take a brief example of taking base 2 representation. For example, if you want to take 9 into 2 you just need to divide 9 by 2. So this is going to be equal to 4. The remainder is going to be equal to 1. Right? So the remainder is going to be equal to 1. And then, same thing. Divide by 2 again, right? And then it's going to be 2, a remainder equal to 0. And then 2 divided by 2 is equal to 1. So it's going to be like 1, 0, 1, 0, which is 2 to the power of 3 plus 2 to the power of 3 plus 2 to the power of 1. Alright, this is going to be 1, 0, 0, 1. So it's going to be exactly the same. So what is the remainder of 1 and 1 is divided by 5? You can just calculate all that, then just calculate the remainder. So 9 to the power of 0 is going to be equal to 1. And 9 to the power of 1 is 9. 9 to the power of 2 is going to be equal to 81. 9 to the power of 3 is going to be equal to 729. And 9 to the power of 4 will be equal to 6,561. So these are mathematical expressions to do that. And then we add up all these together. These two plus get 10. These two plus get 91. And 91 plus 729 will be roughly 800. 820. So 820 plus this thing divided by 5, right? So 820 plus 6561 divided by 5. You can obviously see that the remainder is 1. So that's why we choose. Next one. This is a very considered as a very hard question in advanced algebra. So first, I'll give you like 5 minutes to have a look at it. A hint for this question is that we'll be applying binomial theory. Will be applied. So by the binomial theory, each term in the expansion of the form will just be given in a combination form, which is 1,000 and k multiplied by first term, okay? First term that is in the order, then multiply y times square root 3 to the power of 1,000 minus k. But this one already deduced the k's power. And then this one will be equal to the right hand side of 1,000 over k. Not just the 1,000 over k times k, into the binomial expansion for this combination. And to the power of k over 3. Because this is 3 right here. To the power of k over 3 times 3 to the power of 1,000 minus k over 2 times x to the power of k times y to the power of 1,000 times k. So this is one binomial original form of binomial extended forms. So k here, the k will be sort of belonging to any integer between 0 to 1,000. So I'll just say k will be belong to integer, and k also belongs to this domain, open bracket, 0 to 1,000. So the problem is equivalent to talking will be equivalent to counting the number of k such that k over 3 and 1,000 minus k over 3 are integers. So a correct value will be 1, which in this case satisfies that k over 3 and 1,000 minus k over 3 are integers. Note that k must be a multiple of 3 and a multiple of 2. So k also has common factor of 3 and 2. So it must have a multiple of 6. Must have a multiple of 6. So there are 167 such values k. Here, remember what I said about this, they will be rational. Here, these are rational coefficients. So it's very important to know what is rational coefficients. Next one. The angle bisector of the acute angle formed at the origin by the graphs of the lines y equals to x and y equals to 3x has equation y equals to kx. And it's asking for k. This is a little bit hard geometry question, so I'll give you like 5 minutes to have a look at it. So this is going to be a coordinate geometry problem. We know that the polar function for coordinate geometry will be exactly like how it's processed during the time that the additional lines are formed. So it's very easy to draw a horizontal line around here as the complementary um, would show horizontal line down here, okay, which intersect this coordinate as B point, C point, A. And we need to let O be equal to X, X, not, okay, and A equal B. Since A is located on Y to the X, then we can set A equal to be 3 and 3. How about that? And then C will just be equal to the coordinate of C will just be equal to 3 over K multiplied by. Okay. And then the coordinate of B will just be equal to like 1. Mathematically. Okay. The coordinate of B will just be equal to 1, 3. And then therefore we can just express all the things that we want. So draw BK perpendicular to x-axis intersect x-axis at 1K. According to Pythagoras theorem. According to Pythagoras theorem, we have OB squared equals to BK squared plus OK squared, which is what we already know. So that one OB will be equal to square root. We'll use a different color to mark and then we just for it. So this one is going to be equal to square root 10. Let OA will be equal to 3 square root. And therefore, OA, OB, AC, and BC will all be added up. BC will just be equal to the horizontal component of C minus the horizontal component of B, which is 3 over K minus 1. And L AC will be the horizontal component A minus horizontal component of C, which is 3 minus 3 over K. So all set up. So the K value for it will just be equal to BK. I'll draw this one down here. Draw this one down here. CH. Since the area BCHK represents a rectangle, so BK must be parallel and equal to CH. So K will be equal to CH over OK plus KH, which is 3 over 1 plus K over 3 over 1 plus K over. Okay, will just roughly be equal to, I'll say 3 over 1 plus k over 3, which is roughly equal to square number, which is 2. So by applying, so this is not done yet. By using angle bisector theorem, we know that OA over OB will be equal to AC over BC. Since AC and BC are bottom side, and OA and OB are like adjacent side, so you can get this form. Therefore, 3 times square root 2 over square root 10 will be equal to 3 minus 3 over k over 3 over k minus 1. So we are going to solve this equation by rationalizing the numerator and denominator. By rationalizing numerator and denominator, we just get square root 2 over square root 10 equals to k minus 1 over 3 minus. So 1 over 5 will be to this whole ratio, which is k minus 1 squared over 3 minus k squared. And then the last thing we need to do is to solve this quadratic equation. The quadratic equation that we come up will be 4k squared minus 4k minus 4 equals 0. And then by simplifying the coefficients, we reduce 4 on the second order term, first order term, and 0 at the same time. So k will be equal to 1 plus or minus square root 5 over 2. So A could be the potential circle. And since k is in the first form, k is in the first quadrant, so k has to be greater than 0. So k equals to 1 minus square root 5 over 2 with 2 plus. Therefore, for this question, choose A. Another function problem. How many ordered pairs of positive integers b and c exist where these two second order equations do not have distinct real solutions? When they do not have distinct real solutions, it theoretically means that this one doesn't have a root. Like this thing doesn't have a root, or the determinant is equal to 0. So when a quadratic equation does not have real solution, it can only if the determinant is non-positive. So the discriminant of a function, okay, of a second order function, is delta equals to b squared minus 4x. If this one is smaller than 0, then the function will not have distinct roots. So we can conclude from equation 1, equation 2 as a vector b and c. And from 1, since the equation x squared plus bx plus c does not have a real solution. So, so, so I think b squared minus 4ac will be smaller than 0. So what is a? A is the coefficient of 1. Therefore, we have b squared smaller or equal to 4c. And the same thing from the second equation, you can get b squared smaller or equal to 4c from equation 1. You can get c squared smaller or equal to 4b as a matter of equation. So squaring the first inequality at the square, we have and also multiplying the second inequality by 16, so we can get like a shorter equation b squared smaller or equal to b squared to the power of 2 smaller or equal to 4c squared. So therefore, under this condition, we also have 4b to the power of 2 smaller or equal to 16c. And then therefore, by multiplying the second inequality with 16, we get the fact that 16c squared is smaller or equal to 64b. So this is how we get the final answer combining these two parts. So 16c squared smaller or equal to 64b greater or equal to b to the power of 4. Next step will be just applying k squared to the value. When b equals to 1, 1 will be greater, smaller or equal to 16c squared, smaller or equal to 64. So c will be ranging. C squared will be ranging from 0 to 4, so therefore c can be chosen as 1. Same thing. If b equals to 2, then 16 will be smaller or equal to 16c squared, smaller or equal to 128. Then c still choose 102. And then for b equal to 3, when b equals to 3, then 81 will be smaller or equal to 16c squared, smaller or equal to 192. Then c can be chosen as 3. When b equal to 4, same thing, c can be chosen as 4. So there will be correct values as 4 is 1, 1, 1, 2, 2, 1, 2, 2, 3, 3, and 4, 4. 3. So this is going to be the correct one. So a lot of these 25 questions have a really, really significant calculation process, and usually by writing down all these notes takes a lot of time, maybe more than 3 minutes. So what I suggest is you can use specific value theorem, substituting specific or strange values into the equation. Then you will get more about it. And also don't forget that for this problem, since the general equation of ax squared plus bx Class C, we have to know several important things. First is the sum of two roots equals to negative b over a. Second one, the product of two roots equal to c over a. Third one, the discriminant will be equal to b squared minus 4ac. When this one is greater than zero, then two different roots, right? Two different roots. When this one is equal to zero, then I have two equal roots. Then when this one has uh, smaller than zero, then when the discriminant is smaller than zero, then it has zero roots. Zero roots. So this is a very, very long tutorial, and after you watch it, please just write down all your notes again. Um, just review this class. This class contains a lot of important information on AMC 12 and a lot of algebra techniques that can be applied on AMC 10 and AMC 8 at the same time. Again, my name is Harvey, and if you have any math, physics, and chemistry problems, feel free to contact me. I would love to explore the world together with you. Thank you very much for listening, and have a great day.